Okay, so as I can see, everyone has answered. One of the student hasn't answered. Please answer, students. So we'll quickly start our session. Sorry for the delay. Okay, give me 1 minute and please answer, students. Everyone. Good evening, Davangere students. Good evening, Bellary students. Okay, I'm ending the poll. Okay, and students who are joining from YouTube. Good evening. Welcome to today's class. Okay. Sorry, audible. Okay, no problem. Okay. Sorry. So, welcome, students. My name is Samanvit, and I'm a physics faculty from Avantifellows. So, students, what were you talking about? We were talking about Newton's laws of motion. We have studied lot of things. Davangere Ballard students, it's audible now, right? Yes. So, yeah. Okay, cool. So, okay, Chitradurga students, welcome to today's class. I guess you are joining for the first time, right? Let me know in the chat once. Okay. So, students, we were talking about what Newton's laws of motion, and we have studied a lot of things till now. Yes, a lot of things. In today's class, we are also going to study a lot of things. Okay, because yesterday we had certain technical issues and all, so we had to let's say end our class very early. Okay, so in today's class, we'll quickly recall whatever studied. Okay, then we'll talk about kinetic friction, students. See, already we have talked about which and all friction. We talked about what static friction. Yesterday we talked about limiting friction, but only certain things. But today we'll be completing it very soon. Then we'll quickly jumping into kinetic friction, students. Then today we'll talk about angle of friction. Then we'll talk about angle of what repose or sliding. All these concepts are very small concepts and very easy concepts. Okay. Then students will talk about acceleration of body down a rough inclined plane. Let's say if there is an inclined plane, and there is a body, what will happen to the acceleration? Okay, when there is friction that is available. Now friction is available. Then we'll talk about a numerical. Then we'll talk about the work done in moving a body up a rough inclined plane. Is it good, students? Are we good to go? Let me know, students, in the chat. Okay, Uttarakhand students, welcome to today's class. Okay, good. Very good. Then students. Okay, sweetie, let me know in the chat. Okay, thank you. Madhya, welcome to today's class. Krishna, welcome to today's class. Good evening, Uttarakhand students. Now, talking about what we have studied in the last class, students. See, in the last class, we were talking about what? Limiting friction. Yes, where we told that as we increase the applied force, see, there was this mass and there was this applied force that we were applying. Now, as I said, we talked about what? The maximum static friction. Yes, and this was called what, students? This is basically the limiting friction. Basically, what is happening is, let's say your Fs max is what? 10 Newton. Now, students, if the applied force is 1 Newton, 2 Newton, if you're increasing the forces, and a stage will come, let's say 10 Newton, when there is a verge on moving over the other. Yes or no? Now, this verge is basically comes when there is what? A limit to the friction. The static friction that was being applied, it came to a limit. Yes or no? Yes or no? The static friction was like, I can't hold the body anymore. Now, the static friction is the stage is obviously maximum. Yes, see over here the static friction, which is a variable quantity. it was applying, that is 1 Newton, 2 Newton, up to what, 9 Newton. When the 10 Newton was applied, it said, okay, it is a maximum static friction that I can apply. Yes, I can hold the body. Now this maximum value was known as what? Limiting friction. Yes or no? It was called F limiting. Basically, initially we used to call it as what? Fs max. Yes or no, students? And we had a formula for it. What is it? F limiting friction is what, students? Let me know in the chat. That is mu s into n. Yes or no? Yes, where mu s is the coefficient of static friction and n is the normal force. N is the normal force. Yes, students, let me know in the chat. Okay. Then what? Limiting friction is the maximum opposing force that comes into play when one body is just on the verge of moving over the another. Yes. See, over here, as I said, there are two surfaces. This body will have a relative motion with another relative motion. Yes. When there is a verge to motion, that in that verge, there is this maximum limiting friction. Yes. Yes, students, let me know. YouTube students. Okay, Ria, let me know in the chat now. Is the screen clearly visible now? Sorry, I guess there was some network, let's say slow network for that. Let me know. Yes, okay, good, very good, very good. Now, next. See, as I said, what? There is certain loss of limiting friction. Loss means is basically tells what is this limiting friction, what are the formulas. The magnitude of force of limiting friction between the surface of two bodies in contact. That is, if there are two bodies that are in contact, and the force of what? Limiting friction. That is F limiting. That is being, if there is force in this, applied force is in this direction, and you know the what limiting friction is in this direction is directly proportional to the normal reaction. Obviously, yes or no? This is the normal reaction. If it is more, if there is more normal reaction, what will happen? There is more limiting friction. So it is told to be F proportional to normal, directly proportional to normal. And if you take the proportionality constant, we get F mu s. Yes or no, students? Yes, this also. So when the body is heavy, what is happening? The normal reaction is increases. Yes or no? How? See, we know that N is equal to mg. See, there is a mg that is acting and there is a normal. Now you know that this normal is equal to the mg. Now students, heavy matlab kya hai? Heavy andre enta. Heavy andre, the mass is more. If the mass is more, then obviously the normal reaction is more. Yes or no, students? Let me know. Yes. Yes. Okay. Very good. So what will happen? See, if n increases, then obviously F will increase. Obviously the F will increase. Yes, that is what. This means more force is required to move a what? Heavier body than the lighter body. That's all. Because why? Because there is what? The limiting friction is more. See, if n is more, then limiting friction is more. Limiting friction is more. Yes or no, students? Let me know in the chat. Yes. Okay. Good. Very good. Now, then what? What were the other things that we had to study? See, here, the direction of force of a limiting friction is always opposite to the direction in which one body is moving over the other, verge of moving. Yes or no, students? As I said, if there is a body and if it wants to move in this direction. So basically what it is saying, see, when the applied force is greater than the limiting force, then there is movement. Yes or no? Students? Yeah. When there is applied force is more than the limiting force, then there is movement. Then what is happening? There is what? This limiting friction that is being acted. That is what, students? F limiting is in the opposite direction. Yes, which is basically opposing it. Yes, very good. Then what? The force of limiting friction always act tangentially. See, over here, you know, if there is two surface, then over here, okay, just a second. This is the tangentially that is being acted. It won't act over here. It will act over here. It won't act over here. It will act over here, students. That is what? F limiting friction. It will act tangentially. Yes. Okay. Good. Good. Now these were the things that we talked. Also, what the limiting friction? The force of limiting friction is independent of the apparent area of contact. Obviously, right? Why? See, we know that F limiting equal to mu s into n. इसमें is there any area component? Is there any area component? No, right? If there is no area component, then it is independent of area. Yes, all these things we have talked in the last class. Then what? The force of limiting friction between two surfaces in contact depends on the what? Nature of the material. As I said, why? Because mu s depends on the nature of material. Nature of material, coefficient of static friction depends on nature of material. And what? Which is in surface. If there are two surfaces, what are the two surfaces that are in contact and their state of polish? See, you know that let's say the material depends. See, there are rough materials, then there are polished materials. Yes or no? Over here, you know that if the surface is polished, then it's very easy to slide. Yes, means what? The friction is less. Yes or no? So it depends on the state of the material also. Sorry, state of polish also. Is it good, students? Let me know. Let me know till now, please. Okay, sweetie, thank you. I hope everyone has understood. Now, students, what we'll be doing is we'll be talking about something other than this limiting friction. That is what? That is kinetic friction. Now, when you hear kinetic, what comes in your mind? What comes in your mind? Let me know. Say everyone, every student has to, every JNV students has to interact. So Bagalkot students, Ballari students, Davangere students, Tumkur, Uttara Kannada, Chitradurga, lot of students are there. Yes, yes, what? There is something motion that is involved. Yes, very good. So can you guess when this kinetic friction will come into picture? Yes, see, can you guess when this kinetic friction will come into picture? Let's take a body. Okay, let's try to understand this. Very good, Tumku students. Try to understand this. Okay. Yes, very good, Uttarakhand students. Understand this using a problem. Okay, using a problem. Now, there is a body, and it is along the surface. Okay, along this surface. Now, this is a 2 kg body, and there is a 20 Newton force is applied. Now, it is given that mu s is equal to 0.6, and there is something else that is given, that is mu k, which is equal to 0.2. Okay. Now the question says, find what? The friction force. This is the friction force. They want to find the friction force, and they want you to find what is the acceleration. Now here, students, what is the first thing that you need to do? Or when you hear the word friction force, which is the friction force that is required to be find it out, to be found out? Let me know. Ria, let me know in the chat. Everything clear now? Let me know, students, which is the friction force that needs to be find out. I mean, is this the static friction? Is this the limiting friction? What is it? Or you can say kinetic friction too. What is it? See, remember, students, whenever there is something like this given, now there is what? One is mu s, one is mu k. You know what is mu s? That is static friction. Now, students, we need to check whether the limiting friction is greater than the applied force. Yes. Why? If this is greater, then there is motion. Yes. Now, as you only said that when there is motion, students, remember, there is this kinetic friction. Kinetic friction. But concept is this, that's all. I'll tell you exactly the concept, don't worry. But just remember, when there is motion, there is a kinetic friction. Now, students, when I am going to talk about limiting friction, F limiting equal to what? Mu s into n. Now, Over here, here is the normal force, here is the weight that is acting. Okay. So I'm asking whether there will be motion or not. Tumko students. Weight is equal to m into g. Yes. Now the normal is equal to what? M into g. Yes or no? That is what? 2 into 10. That is 10. 20. Okay. Is it good? Okay. Very good. How Tumkur students? Let me know. How there is motion? How can you tell there is motion? Now you know that mu s is what? Mu s is 0.6. Normal is 20. So how much is it? Is it? It's 12 Newton. Yes. The limiting friction. It is not static friction, Tumku students. It's the limiting friction. Static friction is according to the force that is being applied. So you can't say it's a static friction. As I said, see, whatever you are going to find out, it's the limiting friction. It's the limiting friction. Yes, very good. See, over here, the limiting friction came out to be what? 12 Newton. That is what? F limiting. But over here, the applied force is what? 20 Newton. Okay. Now, since the applied force is 20 Newton, which is greater than F limiting, then what? There is motion. There is motion. Now, students, I want to ask you, if there is motion, will there be any static friction? If there is a motion, will there be static friction? Let me know. If there is motion, will there be static friction? No. Yes. See, when there is motion, there is no static friction. Or what? It has crossed the what? The limiting friction, limiting static friction, basically limiting friction, maximum static friction. Now, students, now you know that, now you got the idea that this friction force that is needed to be find it out. What Uttarakhand students, what did I write ulta? What ulta did I write? Which one? Which one? What ulta did I write? The applied force is greater than limiting force. Yes. So if that is the case, oh yes, yes, yes. Here. What? If the applied force is greater than the limiting force, then there is motion. Yes. Very good. Very good. Thank you, Uttarakhand students. Very good. Now, see, as I said, now you know that this friction force that need to be found it out, to be found it out, what to be found is what? Not static friction or limiting friction. Now, students, as I said, see, let's take the wardrobe example. Okay. Now you want to move this wardrobe from one room to another. Okay. Now you applied force, you applied more force, and it's trying to move. Now, when it's moving, students, I want to ask you: is there any sound? Krrr sound. ನೀವು push ಮಾಡಿ try ಮಾಡ್ತೀರಿ. Will there any krrr sound? Yes or no? Let me know. Sweetie, Trishna, let me know. Chitradurga students, push ಮಾಡ್ತಿರ್ತೀರಾ. If you're trying to push it, okay, you're applying force. There is a motion, but there is some krrr. Yes. Can you hear it? Did you hear it? Did you hear this sound? Yes. Yeah. Now this friction is due to the motion, and that friction that comes into, if there is motion, that friction that comes into picture is what? F kinetic friction, students. That is the kinetic friction. Yes. That is the kinetic friction. Now, this kinetic friction is also has the same formula to find it out. What is it? F kinetic is equal to mu k n. That's all. Where mu k is what? Coefficient of kinetic friction. What? Coefficient of kinetic friction. That's all. Now, as I said, here we need to find what, students? We need to find the friction force to be what, students? What is the friction force? The kinetic friction force. So how can I find out? Fk is equal to mu k into n. Now, students, mu k is what? Fk is equal to mu k is what, students? Let me know. Mu k is 0.2 into 20. N is 20. That is what? That is 4 Newton. Fk is 4 Newton. Now, can you observe here? The F limiting friction that we got was how many? 12 Newton. And F K got was how many? 4 Newton. So always remember, students, Fk will always be smaller than F limiting friction. Can I ask you why? Can I ask you why? I'm asking you. Okay, may I know why it is? May I know why it is? Why this kinetic friction value is less than the limiting friction value? Obviously, right? See, over here, there is motion, but we want certain motion. If the kinetic friction is very much, obviously there won't be any motion. So with motion, there is some friction. Is it good? Is it good, students? Let me know. Okay, sweetie, thanks. Davangere students, thank you. Others? Others? Let me know. Yes. So that was the case. Now, students, so what we got, see, over here, there was a body which was applying a force of how much? 20 Newton. And we got a friction force, Fk is equal to 4 Newton. Okay, which one, Ballari students? Let me know. Which one should I explain? Okay, see, I'll tell you what. Now, this limiting friction is basically what? Whenever there is a verge of motion, this limiting friction comes into picture. Yes. Okay, full. From kinetic friction, full. Padari students. Sweetie, I'll tell you, okay? See, over here, as I said, whenever there is motion, see, first thing what we did, there was 2 kg mass and there was a 20 Newton applying force. Yes, Padari students. Now, the question says we want to find F, that is friction force. Now, the friction force that needed to be find it out, we need to see whether it is static friction or limiting friction or what, or some other friction. Now, we check that what the limiting friction, the maximum, that is the maximum static friction that we get. Basically, what Fs max also, the limiting friction that we got was what? 12 Newton. As I said in the previous class, if the applied force increases the what? Limiting friction, then what will happen? There is a motion. Now, we know that if there is motion, Ballari students, if there is motion, then static friction won't work or limiting friction won't work, because limiting friction andre anta. Limiting friction andre a limit tanaka there won't be any motion. After the limit crosses, obviously there will be motion. Yes. Now, as I said, we need to find the kinetic friction. Now, in order to find the kinetic friction, this is the formula. The formula is same. That is what? Fk is equal to mu k into n. And this mu k is what? Coefficient of kinetic friction. Now, I got the formula and I put the formula. Fk is equal to 0. It is given in the question. This is 0.2. I put 0.2 into 20 because n is equal to m into g. So we got m is what? M is 2 kg and g is, see, I take it as 10 meter per second square. 10, that is 20. So I applied it, I got 4 Newton. Now, Sweetie and Ballari students, see here. We got the limiting friction as 12 Newton and kinetic friction as 4 Newton. Over here, you can see that Fk is smaller than limiting friction. See, why the limiting friction is small or greater than the kinetic friction, or the kinetic friction is greater than limiting friction? As I said, see, what does limiting friction do? See, you applied, let's say, in yesterday's class, see this F over here in this also, we got the limiting friction as 12 Newton. As I said, if I applied 1 Newton, 2 Newton, what will happen? They'll be acting what? A static friction, Fs. Fs will be acting, that is what? 1 Newton, 2 Newton, up to what? Up to 12 Newton. Yes or no? And after the 12 Newton, if I'm applying 13 Newton, then what will happen? The body will move. Yes. See, over here, the kinetic friction is acting such that there will be motion. बट मान लो अगर उसमें ज्यादा फ्रिक्शन डाल रहे हो तो मोशन नहीं होगा ना, तो इसलिए काइनेटिक फ्रिक्शन तो कम ही होनी चाहिए। किससे? कौन सी? लिमिटिंग फ्रिक्शन से। यस और नो? सो दैट इज व्हाई द काइनेटिक फ्रिक्शन will always be less than the limiting friction. Yes, did you get it now? Let me know, students. Let me know. Ballari and Sweetie, Uttarakhand students, very good. Sweetie, let me know in the chat. Davangere students, okay. Balapur students, very good. Okay. Now, students, you know that what? Okay, good. Thank you. Fs and sorry, F limit and Fk is what? Mu s, mu k into n. So if Fk, yes, okay. If Fk is less than F limit, then we can say that mu k will always be less than mu s. Okay. This is also case. So what is it? Fk will always be less than F limiting friction, and what? Mu k will always be less than mu s. So this is an important result. Okay. This is an important result. Now our work didn't stop here, students. Our work didn't stop here. Over here, students, we wanted acceleration also. We want to find acceleration. Yes. How do we find acceleration? Students, see, question clearly says, we want what? We want acceleration also. How can we find acceleration now? Students, let me know. How can we find acceleration now? Yes, very good. Okay, this is the FBD. You know that this is the 20 Newton force. This is 2 kg. This is what? The normal force. This is mg. Now let me tell you what it will be then. How can I find? Force formula, okay. But can we apply force formula? Can we apply force formula? Yes. See, over here, now since the body is motion, can I say this along this side, there is this 4 Newton, that is force acting. So you know that acceleration is equal to what? F net divided by what? What mass? This F net is what? F net, can I say 20 minus 4? 20 either, 20 either, or acceleration over either. So 20 is greater than 4. 20 minus 4 divided by what? 2. That is what? 16 by 2. And Tumku students are told 8 meter per second square. And that is the right answer. Did you get now? F is equal to m into a. That is the concept that we applied. That is second law of motion. Yes. That is the second law of motion that we applied. Is it good? Let me know, students. Did you get it? How to find out the acceleration now? Let me know. Students, let me know in the chat. Okay, but students are strict. Okay, good. Krishna, is it clear? Okay, very good. Ria, let me know in the chat. Okay, Aishi, Amrita, anyone? Okay, good. Now, see, we have explained, I have explained everything. Now we are talking about the what in terms of what definitions. What does the definition says? Kinetic or dynamic friction. Sometimes you say dynamic friction, sometimes you kinetic friction. It's one and the same. Is the opposing force that comes into play when one body is actually moving over the surface of another. So what? If there is body and if it is moving, and if this is the surface, what will happen, students? What will happen? Then there is this kinetic friction that will be applied. Is it good? Let me know, students. Let me know. Okay, good. Now, what? There are certain laws of kinetic friction. What does that say? The first thing is what? Force of kinetic friction is directly proportional to the normal reaction between the two forces in connect. So what does it say? The kinetic friction is proportional to the normal force. Yes. So basically what? Fk is proportional to normal force. And if I remove the proportionality constant, I get what? Mu k into n. Yes. So this is the formula to find out that we have already talked about. Yes. And what? Kinetic friction doesn't depend on the surface area in contact. Obviously, why? Because there is no area in formula. Yes, there is no area, so it doesn't depend on the surface area. what? And force of kinetic friction is independent of the speed of sliding or rolling. Yes or no? See, it doesn't, see over here, whatever the speed with which it will move. Okay, let it move 6 meter per second, let it move 7 meter per second, let it move 8 meter per second. Whatever the kinetic friction that comes into picture, the value, it always be what? Constant. It always be constant. As in, let's say I got Fk is equal to 0.4. Now, for all the velocities, it will be what? 0.4. For all the velocities, what? The Fk will be what? Constant. Okay, so it doesn't depend on the speed it moves. So when you're pushing, whether you're pushing hard, or you're pushing slowly, or pushing very, very fast, it doesn't matter. The kinetic friction will remain same. Yes? Let me know. Yeah. Okay, good. It would be very nice if you text in the chat, okay? Because your emoticons are visible in the other section. So sometimes I feel you are not replying. Okay? Good. Now we'll be talking about a graph. A graph is basically graph between, okay, let me do it very nice. Okay. Let me do it very nice. Graph between, basically, what is a graph between the friction force and what? The applied force. Now students, see the scenario that I was saying. See, if there was a body and it is over here and I was applying certain forces, okay, applied force. Now, as I said, if the the limiting friction is what, let's say 10 Newton. Now students, if I'm applying 1 Newton force, then what? The body won't move, but there is a static friction that is being applied, that is 1 Newton. Yes. Then if I apply 2 Newton of force, then the static friction is what? 2 Newton of force. Yes or no? Yes or no, students? Let me know. Yes. So can I say, as I increase the applied force, the static friction will also increase linearly? So can I say this static friction basically increases linearly? Like as I increase my force, this is my static friction. Basically, this represents what? The static friction. Yes? Yes or no, students? Let me know in the chat. Now, see, as I said, there was a limit when the applied force came out to be what? Let's say the limiting was 10. So up to 10 Newton, yes. So after that, what will happen? If I'm applying 10.1001 also, then what will happen? It will go to motion. Yes or no? Yes. After the motion, what will happen? The kinetic friction will come. Yes. See over here. So can I do something like this? After this, there's a bump. Yes or no? So what will happen? The friction force changes to what? To basically F, limiting friction. There is a limiting friction. Now students, after that, the kinetic friction acts. Yes, the kinetic friction, as I said, it will be what? Constant. So here is, this is what basically the kinetic friction. The kinetic friction. So here is a graph between what? The applied force and what? Between the friction force. Let me know in the chat, students, did you understand the graph? Let me know in the chat. Let me know. Yes. Yes, okay. Others, let me know in the chat. So can I say this portion is basically what? This portion is basically static friction. Yes, very good. Over here, the bump is why? Because see, after a limit, it changes to what? Fk. It changes to Fk. That is what. Yes. After a limit. Yes. And what? As I said, the static kinetic friction will remain constant. Very good. Others, let me know. Okay. Trishna, sweetie. Okay, sweetie has answered. Thank you, Trishna. And YouTube students, let me know. YouTube students, let me know. Okay, good, good. Now, students. Now, we'll be talking about. Okay, tumko students, very good. Now, we'll be talking about this angle of friction. What is this angle of friction? It is very, very, very easy, students. Just listen to this. Over here, let's talk about this now. Okay. The angle of friction between any two surfaces. Okay. So there is a body. Okay. There is a body. There are two surfaces. One this body and there is a surface over here. Okay. And you know that is mg is acting, or normal is acting, and mg is acting. Okay. And a force is acting. Now, the angle of friction between any two surfaces in contact is defined as the angle which the resultant of force of limiting friction F. Basically, see, as I said, if there is force, then there is friction force, and this friction force is, let's take it to be the limiting friction force. Okay. Now, students, what the resultant between normal and frictional force is this? Yes or no? Is this? Yes. Let me know in the chat. Will this be the resultant? This one. This will be the resultant. Yes. Just a second. This will be the resultant. Yes. Yes. Okay. Now they are saying that the angle which is a resultant of force, this resultant of force of limiting friction F and the normal reaction makes with the direction of normal reaction. Basically, they are saying this angle is what? Let's take it to theta. This is what, students? Angle of friction. बस काम खत्म. इतना ही था. लेकिन इसको फाइंड आउट कैसे करते हैं? मुझे ये बताओ, ये F जो है, फोर्स, लिमिटिंग फोर्स जो है, वो एक वेक्टर क्वांटिटी है. इज इट वेक्टर? ऑब्वियसली राइट, फोर्स है. इज इट वेक्टर क्वांटिटी? यस. नाउ स्टूडेंट्स, ओवर हियर कैन आई डू समथिंग लाइक दिस? Over here, there is this normal that is acting. There is this resultant that is acting. The friction force was acting over here. The friction force was acting over here. Can I shift the friction force over here? The friction force over here. Yes? Yes or no? Since it's a vector, we can shift it. Yes or no? So you have studied, we can shift it. Okay? So this is angle theta. Yes? Now this is what? Normal force. Yes, students? Okay, very good. Sorry. Yes, let me know. Okay. Okay, students. Now what is this? This is normal. This is the friction force. Now, students, what is tan theta? What is tan theta? What is tan theta, students? Let me know. Opposite side by adjacent side. That is what? F limiting force divided by what? Normal. Sine by cos. But over here, is it F limiting force divided by normal? Will it be? Will it be F? What? Tan theta equal to F limiting force divided by normal. S? Yes or no? See, I over here, I took the F limiting. As I said, this is what? The limiting force. And this is the angle theta. So what? Tan theta is opposite side by the adjacent side. This is normal. Yes or no, students? Let me know in the chat. Yes or no? Our resultant force opposite. Okay, just a second. Ballari students, always remember, okay? How resultant force opposite side come? I didn't get you. See, wait. Okay, Ballari students, see over here the definition says that the angle made by the what? The limiting force and the normal. See, over here the limiting force. Yes, the limiting force is along this side. The normal is along this side. Obviously, the resultant will come along this side. Yes, yes, very good, very good. Now, see, students, You know that there is one formula here. We know a formula. What is that formula? We know F limiting equal to mu S by N. Now, what is F limiting by mu S? Sorry, F limiting by N, N which is equal to mu S. Yes. So can I substitute over here? So tan theta is equal to what? Mu S. Yes. So theta is equal to what? Tan inverse of mu S. Now this is the formula to find the what? The angle of friction, students. So what? Angle of friction is what? Tan inverse of what is this? Coefficient of limiting friction. Bus. Coefficient of limiting friction. Yes or no, students? Let me know. Yes. Okay, good. Very good. Yeah. Now, students, now we'll move ahead and we'll talk about what? Angle of repose or angle of sliding. Okay, what does it say? Now, let me on my video. Okay, video is on. See, over here, let me take one example, students. Now, let's say here is my object. Okay, see my this thing. Here is my object, and here I have kept an object in my. This is my plane, and I have kept an object. Okay, there is object. If I increase, let's say it is making with the surface. There is a surface. I'm making an angle. Now, students, I'm making an angle theta. Okay, over here. Let me show this side. So over here, this is a surface, and this is a surface. Now, students, if I'm increasing theta, is it getting? It is coming down. Is it coming down? Yes or no? Let me know. If I increase the theta by small amount, is it coming down? Is it sliding? Let me know, students. I'm making so much effort. Let me know in the chat. Yes or no? Students, if this is the angle theta, is it sliding now? No. If I'm increasing the theta, then there will be a point. Let's say if I'm increasing till now, it is not sliding down. But if I come to a point at theta, there will be a point. See, over here, it will start just sliding down. I'm able to feel it, okay? And if I increase the theta, what will happen? This object will what? Slide down completely. Yes or no? Did you get an idea? Did you get an idea, students? See, over here, yes. See, over here, there was a inclined plane with an angle theta, and there was an object. Okay. Now, initially, I kept this angle theta to be 0. But when I increase the angle, there was a point when what? It just slide. It what? The object got what? It started to slide down. Yes or no? Now, students, over here, if this is the object with mass m, you know that there is a weight acting. That is what? Weight is equal to m into g. Now, see, when we were talking about second law of motion, I told you directly that there will be a component that is acting. That is what? Mg sine theta. And there is a component that is acting what? What is that component? This component is what? Mg cos theta. And there is what? A normal that is acting. And yes or no, students? Do you remember this? Do you remember this, students? Let me know. Let me know. Yes. Now, students, very good, very good. Yes, very good. Now, students, see, as I said, over here, this angle of repose, what is it? Or angle of sliding is defined as the angle of inclination of a plane. What is it? The angle of inclination of the plane. Angle of inclination of a plane with the horizontal such that a body placed on a plane just begins to slide down the inclined plane. See, when the body just begins to slide down, so what does it mean? It is in the verge of motion. When there is a verge of motion, students, which friction acts? Let me know. Which is that friction that is acting? Which is the friction that is acting? Let me know. See, it is going to what? Slide down. Yes, very good. That is what? The limiting friction. So can I say this limiting friction to be mu s n? Yes? Yes or no? Now, so what angle we have? We have Ballari students. This one we have talked about in the what? In the let's say in the what? Second law of motion. See over here, if this is the inclined plane and this is theta, now over here there is an object. Let's take point object. Okay. Over here, this is what? Mg. Okay. Now, if this is theta, now you know that there is what? If there's a normal that is acting, and if I'm taking this line, okay, this line and this component, this is theta. Yes, obviously, right? See, this is 90 minus theta. Now you know that this whole angle is what? What, students? 90. Now you know that if this whole angle is 90, then this angle is what? Theta. Now you know that you can what? If this is mg, then you can what? Resolve into two components, that is mg cos theta and mg sin theta. Students, you need to go to the let's say my second law of motion lecture, and you will be able to understand it. Okay, is it good? You need to go there. But are students, did you get an idea? Okay, wait, let me do it. But see, that's the thing, students. You need to see the previous classes. Otherwise, it is very difficult, because if you are not able to, if you are not seeing that, and we are talking about right now friction, so that's not good at all. We have to study. Okay, see over here. Let's take this as my mass m. Now you know that there is a mg that is acting. Yes, mg, and also you know that there is a normal that is acting along this surface. Now I'll extend this normal. Okay, if I extend this normal, now students, this angle is theta. If this angle is theta, this angle is what? 90. Yes or no? And this angle is what? 90 minus theta. Yes, students. Now students, let me know what is this total angle. This is also 90. Yes, if the total angle is 90, if the total angle is 90 and this angle is 90 minus theta, then what will be this angle? This angle will be theta, right? Yes or no? Yes. Students, let me know. Badari students, this is for you. You have to reply. Let me know. Yes. Okay. Yes, very good. So what is happening? So this is 90, this is theta, this is theta. Now there is a component mg. You know that you can resolve the component. You can resolve the component into two components, that is mg cos theta and what? This slide mg sin theta. That is how we got it. Is it good? But are students? Let me know. Yes, okay, good. Now students, see, as I said, there are components and you know that it is going to slide. Now we have what? We have f limiting equal to mu s into n. Now students, can I say over here, n equal to mg cos theta? Can I say it? Students, let me know. Yes or no? Yes. Now students, you can see here there are two things. One is sin theta, one is cos theta. So there are two things, sin theta and cos theta. So remember students, what we are doing, we are going to increase theta. So always remember students, when theta is increased, what is happening? The sin theta will increase and cos theta will decrease. So what? When theta is increased, sin theta increases and cos theta decreases. Now, as I said, students, I will increase the theta and there will be an angle. What? That angle of repose is that angle. What will happen? The body will just start to slide. So I will call it alpha. So can I say students, this angle of repose, can I say that this angle theta, that is what inclination angle, to be alpha. Yes or no? So I'm increasing the theta, theta, theta. So there will be a point that is alpha where the body will slide. Yes or no, students? Let me know. Let me know in the chat. Yes or no? Yes, very good. Sweetie, very good. Okay, very good. Yes. Now, students, over here, observe. Over here, which is the force? Which is the force that is what it is making sure that this slide, this body don't slide. This what limiting force. So write? Can I write at this angle of response, mg sine alpha equal to mu s mg what cos alpha? Can I write it? Can I write it, students? Let me know. What? At the angle of response. Yes or no? Now, mg cancels out, mg cancels out. We get sine alpha equal to what? Mu s cos alpha. Now, students, can I write sine alpha by cos alpha equal to mu s? Now, can I write it as tan alpha equal to mu s? And alpha is what? Tan inverse of mu s. And this is what the angle is. Angle when what will happen? The body will what, students? Slide on, begin to slide on. Slides. Did you get it now, students? Let me know, students. Okay. Yes, sweet. I'll tell you. Okay. Don't worry. I'll tell you. Over here, you know that. Okay. I'll use this example. Okay. Or let me take this example. Let me do it again. I'll draw it again. Sweetie, there is a body. Okay. Just a second. And others too. There is a body. M. And you know that this is mg. And there's a normal force that is acting N. This is what? Mg sine theta. And this is what? Mg cos theta. Yes. And this is theta. Yes or no? Now, as I said, at an angle alpha, what that is angle of response, this will start sliding, or what? Verge of sliding. Yes or no? Now, when you're increasing the theta, which is that force that is making sure that this body don't slide down? What is that? That is the limiting friction. Angle of friction. Wait. See, that is what? That is the formula that you got in a separate two instance. Okay. Here you can't say that, because here the angle of response is what? Increasing the angle. Yes. Did you get it? Over here, we had a different formula, different concept over here. Okay. We had a different concept over here. That is a resultant angle between the resultant force. Okay. Now, tumko students, did you get it? That is the what? Angle between the resultant. Here we are getting using the formula. So you can't relate it. Okay, in formula wise you can say it, but you can't relate it. Okay, you can't say that. Now, sweetie, this, as I said, when there is this verge of what? Sliding, the limiting friction acts, that is mu s into n. Now, sweetie or others, can I write this limiting friction to be mu s into n, which is basically, now you know that this n is equal to mg cos theta. Yes. So F limiting is equal to mg cos theta. Yes or no? Yes. Okay. Wait. Tumko students, just a second. Okay. So this is mg cos theta. You got it. Now I'm asking this force. Basically, this force will make sure that what this limiting when this what force is applying, mg sin theta is applying. This limiting force is acting along this opposite side. Yes or no, sweetie? So can I write? Can't I write mg sin theta is equal to mg cos theta? But as I said, this theta is what? Alpha. Because at this angle only this sliding takes place. So can I write mg sin alpha is equal to mg? Oh, there is mu s. There is mu s. Mu s is missing. Mu s. So mg cos alpha mu s. Sweetie, yes or no? Yes or no? Ha, that is why I wrote this. Did you get it now? That is why we got this formula from it. So I got mg sin alpha is equal to mu s mg cos alpha, sin of alpha equal to mu s cos alpha, sin alpha is equal to cos alpha is equal to mu s, and tan alpha is equal to mu s. Okay. Yes. Tumko students, see, I do agree that what the mu s is coefficient of friction is same. Yes, static friction, limiting friction is same. But the concept of angle of friction and angle of repose is completely different. Yes or no? This angle of repose is coming when you're increasing the theta and at a particular angle. Yes. Yes or no? I'm telling the concept in terms of concept wise. In value wise, I do agree that it will come what same, because we got what alpha to be tan inverse of mu s and theta to be tan inverse of mu s. But the concept for both thing is different, because theta is the angle between what the resultant basically. Okay, is it good? Let me know in the chat. Okay, yes, good. Okay, students. So we had to talk about what acceleration on a body down a rough plane. Okay. So we'll be talking about in the next class. In the meantime, students, please answer the NPS and let me know like what should I do better, whether you are able to understand the class or not. Okay. In the meantime, when you are answering the NPS, let's talk about the summary of today's session. What we have talked in the today's session. Okay. What? See, first thing we talk about what? Students, let me know. Do you remember what we were studying in today's class? Yes. What, students? We talked about limiting friction. Limiting friction. Yes, we completed it. We know that F limiting is equal to what? Mu s into Fs. Yes, very good, sweetie. Then we talked about what kinetic friction, which is equal to mu k into Fk. Yes. Then what did we talk about? We talked about what? Theta. Theta is what, students? Angle of friction. Angle of friction. Yes or no? And everyone has to answer the NPS. Please don't leave the class without answering the NPS, students, please. Okay. Yes. Then what? Then we talked about alpha. That is what? Angle of repose. So students, your homework is to derive everything. So derive everything again, and please let me know if you have any doubt. Okay, homework. Okay, students. Yes, let me know. So thank you, students, for attending, and thank you for answering. Okay. Take care, students. Bye bye. YouTube students, take care. Bye bye.